Welcome to the MCAV end of year update on the intersection control algorithm. Over the past year, we have invested significant time and effort into improving the algorithm. As a summary, the algorithm works to maximize intersection vehicle pass-through rate and minimize travel time for intersections. Based on the principle of if you can go, you go, it dynamically allows for autonomous vehicles to actively control their travel while coordinating with nearby vehicles to avoid collisions. Since version 1, we have added additional safety checks, V2Y redundancy rollover, basic collision prediction and detection, and basic congestion resolution. The algorithm is split into 3 separate components. Pre-intersection. Check if the vehicle is close to the intersection and whether or not there is an RSU present. Intersection. If no collision is predicted, go through the intersection, otherwise coordinate with nearby vehicles for travel order. Post-intersection. If applicable, allow the next most appropriate vehicle in the intersection to travel. The team is in the process of developing the algorithm on the FlexBE behavior engine for ROS and then simulating different scenarios on CARLA using Scenario Runner.
Hello everyone, my name is Pudaruth and I'll be speaking about FlexBE and its role in developing and implementing the intersection control algorithm for MCAV. So what is FlexBE? FlexBE is a drag-and-drop graphical interface which allows for the creation of complex robot behaviors via state machines. The program outputs the behaviors created into Python files, which can be executed by its inbuilt launcher. When a behavior is running, it can be modified, forced to transition, halted, and the robot can request help from the operator. In our case, FlexBE will be used to implement and test the ICA in both virtual and real-life applications. So why use FlexBE? FlexBE provides us with some key advantages when compared to traditional implementations such as manually coding robot behaviors. These include the highly flexible nature of FlexBE behaviors, which allows them to be composed of standard functionality or system-specific features. Another important feature of utilizing a FlexBE built algorithm is that it can be visualized while it is running. This allows for full transparency regarding the current state of the behavior, control over the flow of the algorithm, and instant troubleshooting if required. In order to gain a deeper understanding of the advantages of FlexBE, we must discuss the use of state machines. State machines allow us to break down a large, complex algorithm into independent units, which are referred to as states. These states can be arranged in such a way that they move procedurally from one state to another, ensuring that the algorithm is always in the correct state at the correct time with the correct information to execute the desired action. So what is my role? My role in the MCAV team is to implement the intersection control algorithm in FlexBE. This entails transferring the flowchart version of the ICA into state machines within FlexBE. My progress so far has been the creation of basic test behaviors as a method of learning how to use the software and understand how it interfaces with ROS. In the future, I plan to complete the implementation of the algorithm and proceed to perform several stress tests in a virtual environment in order to identify any of its shortcomings. So now we move on to a short demonstration of FlexBE and what it may look like when the ICA is fully implemented and operating.
Hi, my name is Vivek Sharma, and I will now present the detection algorithm that will be used in the intersection algorithm. So I'll now give a brief overview of the intersection control of the collision detection algorithm. The idea is that two cars will come up to an intersection. They will then send their predicted routes to each other. This will be in a format of discrete data points. The algorithm is then to take these discrete data points and to calculate whether these predicted routes will collide. Figure 1 shows such data point that is harvested on Google Maps from Monash University Clayton campus at such an intersection. It shows two routes that are currently colliding. The current mathematical method that is used in this collision detection algorithm is to fit a second-degree polynomial regression over the discrete data points. This is done in Python and is based on the assumption that most routes can be approximated by a polynomial and that the most routes are roughly polynomial in nature. The algorithm will then see if the curves intersect and reply with a Boolean. I'll now quickly talk about what my role is in this. As my objective, I have to implement the collision detection algorithm in FlexBE as a part of the intersection control algorithm. The task now is to transfer and improve the Python code to FlexBE. So far, the progress is that I've created a simple detection algorithm in Python, and the goal is to have a fully functional detection algorithm in FlexBE tested on various different scenarios. Thank you for your time.
This year, due to extended lockdowns, Connectivity's main focus was researching optimal 4G cellular technologies and LoRaWAN modulation techniques as an alternative. Depending on their price, speed limitations, and information transfer and the installation requirements, the team decided to continue the research of using 4G cellular network on Jetson Nano, looking at both the software and hardware connections.
During the recent weeks, the connectivity team focused on observing vehicle-to-vehicle behaviors using CARLA and Scenario Runner. CARLA is an open-source simulator platform providing AR interaction of real-world infrastructure and the autonomous vehicles that operate within them, along with built-in features such as traffic generation or weather patterns. Scenario Runner can be executed within this CARLA simulator and is the engine based on CARLA that can be used to execute different types of situations. Scenarios are complex choreographies of actors that result in specific traffic situations. These scenarios are customizable and can be modified to create completely new scenarios where agents have to solve and navigate through. These can be created directly from Python or via OpenScenario.
Using CARLA and Scenario Runner, the team is currently aiming to create multiple scenarios with different combinations of factors using CARLA APIs. The team currently brainstormed up to 10 different scenarios to observe these behaviors. A few of these scenarios can be seen in slides. Number 1, when a vehicle is turning into Main Street. And in second example, in case of emergency, like a police car or an ambulance at an intersection, which vehicle will act as an ego vehicle. Regarding our future work, we have 3 main goals. Number 1, we will continue to improve the current documentation on CARLA Scenario Runner and its processes, and we will also be looking into testing and implementing these scenarios in Scenario Runner. Another goal for next year would be to look into how we can integrate FlexBE and CARLA.
The goal for the team by the end of 2022 is to have the intersection control algorithm fully working on ROS and tested in simulations and then implemented onto hardware vehicles. In addition to these, the algorithm will continue to be improved with additional features added for cooperative driving. Thank you for watching and make sure to follow MCAV for more updates.